Hey guys, purpose of this video is to give a little bit more information about how we set up and code in STATA our demographic characteristics and how we set up our scales. We have sort of a standard approach that we use for most of our analyses. Doesn't mean you can't deviate from it if you have a good reason for so doing. But in general, here's what we do. So let me share some information with you. To do this, I'm going to use the exact same files we used with our general STATA do file setup video. So here we have tables from an HIV paper from Project Homes, and I'm just going to focus in on the demographic characteristics so you can see how we set those up. You'll notice, in general, we treat age as a continuous variable with most projects. If you have a good theoretical reason for splitting age, you still might want to do so. For example, in this analysis, because it's HIV, we could have split at 24 as a cut point. So we could have done under 24 and 25 plus because there are interventions targeting young men who have sex with men, for example, under 24 years of age. So if you have that as a theoretical point and you're interested in comparing groups like that, you might make age categorical. But generally speaking, we treat age continuous with a mean and a standard deviation is what we report. For gender in our team is a little bit tricky. On this particular analysis, we excluded trans and non-binary folks because we only had, I think, 2. Generally speaking, in our projects, you will have a fair number of trans and non-binary folks. In that situation, you'll need to go through and do a decision point about whether or not you want to report only the gender by which people identify, or whether you are concerned about biological differences that might be a result of what they were at birth, in which case you need to pay attention to sex at birth, and or you need to do the 2-step method. The 2-step being that we look at sex at birth, we look at current gender, and we look for a match or a mismatch. And if there's a mismatch, then we recode those people as non-binary or trans. An example of where that might happen is someone might say they were male at birth, but they identify as female. Just because they don't identify as a trans woman doesn't mean that we, for our analysis, would not mark them that way. But again, it's theoretical. You have to know why you're doing it. Are you interested in just current gender identity, in which case you mark it whatever they say it is? Or do you care about that identifying folks who did transition? So be attentive to that and thoughtful about how you use gender. And if you have questions about working with trans or non-binary people in your data set, I'm always available to help you. Generally speaking, race, ethnicity, we combine. So in our data sets, we usually ask ethnicity, are you Hispanic? Yes, no. And then we have a separate item where we have race categories, white, black, Asian, etc. Generally speaking, we combine those together, right? Nearly all the time. And we can create a combined race ethnicity variable. So you'll always have Hispanics, and then everything else is non-Hispanic. In this situation, we didn't have a whole lot of non-Hispanic, non-whites, and so we ended up creating this other non-Hispanic group. So we have, for example, non-Hispanic whites, Hispanics, and other non-Hispanic. With larger data sets than this one, this is only a sample of 184, it's very common for us to have black non-Hispanic as well. Unless we have a really large data set, it's hard for us to have Asian non-Hispanic or Native American non-Hispanic, etc. Our data sets tend to not have a lot of those folks because most of our data sets are from Texas and we just don't get enough participation from those other groups. However, if you do have a large data set where you are able to split out other race ethnic groups, you'll always split them out with that non-Hispanic piece. Sexual orientation can be done in different ways. So depending on your analysis, most of the time, our analysis focuses on heterosexual versus sexual minority. Within that sexual minority group, though, we sometimes will break it out. We'll break out gay and lesbian versus bisexual, for example, because bisexual people tend to have more health inequities than gay and lesbians, which tend to have more health inequities than heterosexuals. So by and large, we try to split it out that way, but if we can't, then in this situation, for example, we just collapse it sexual minority versus hetero. So if you have questions about that, again, reach out to me. It's an area I've done a lot of work. Relationship status is another common variable that we use. When we talk about relationship status, we're interested about whether they are in a relationship or not in a relationship. Or sometimes we're interested in whether they're in a monogamous or an open relationship. So you have to think about, again, what is the relationship question that you care about when you are setting this up? Is it important that they are in a relationship versus not? Or is it important, if you're looking at STD outcomes, for example, whether or not they're in a closed or open relationship, and whether or not their partner and they have an agreement or not, right? These are things that we get into with some of our data. The rest of these things that we tend to use are pretty straightforward, but I wanted to go over those nuances on the demographics because they are things that tend to be unique to our work. The other thing you need to consider when you think about demographics is you need to consider, is it a predictor of both your outcome and your explanatory variable, or is it an important explanatory variable? Oftentimes we're throwing in these characteristics as covariates, these demographic characteristics. They tend to be covariates separate from our primary explanatory and outcome variable. If you're going to include them, you need to do a DAG and think about, is there a relationship between that variable, demographic variable, and your explanatory and your outcome. So another classic example, for example, folks like to include income. But if you're going to include income, you need a reason for why you're including it, right? In other words, does income predict the explanatory, and does income predict the outcome? If so, that means it's a confounder and you want to include it. If it doesn't predict both of those, then you really need to have a good theoretical reason for its inclusion. So if you're trying to decide which demographic characteristics to include, don't just throw them all in haphazardly. Have a good reason for their inclusion, and also think about multicollinearity. So for example, if your idea is to put income in as a predictor of socioeconomic status, consider whether education or income or some other characteristic is a better proxy for SES than all of those variables in there together, to avoid issues of multicollinearity or model overfit. Okay, that's a little bit about how we set that up in the tables. What does this look like in STATA? So let's take a peek really quick. This is the STATA code I've already given you guys. This is an example of a do file from Telus, Texas, I believe. And just as a reminder, we always have this at the top of our do file. Every do file begins with telling us the file, the purpose, who the author is, the date, any revision dates, any versions, and the counts of the data, so that we have that at the top of every do file. I'm going to skip past some of this stuff because we went over this in another video, and instead I'm going to scroll down and I want to show you how we set up some of these demographic variables so that they're useful for us. So I'm going to go quickly here, so be patient until I get to what I want. So here we go. So now we are getting into demographic characteristics. And so we're going to start off with age. Here, age is a continuous variable. And so EQ2 was eligible age. We created a categorical variable, so we used EGen. So EGen equals EQ2, the continuous variable, but now it's categorized. And then we created cut points at these different levels. And then we labeled each of those cut points using the label define command. Notice we have modify there at the end. We labeled the values and then we ordered it. You'll see here we have the Spanish and Hispanic thing. So this is the ethnic question. Are you Hispanic? Yes, no. And so EQ3, we labeled it Hispanic. The values were the EQ3 yes, no response option. We ordered it. And then we created the race variable here. So we labeled our race variable. And then here is where we create a race ethnicity variable. And so you can see here, we generated EQ4 is missing. We replaced EQ4 as 1, etc., etc. Look at the code, and you can see down here that we created a variable combining EQ3 and EQ4 to create a variable for Hispanic, white, non-Hispanic, black, non-Hispanic, etc. So here's an example of what that code looks like for you. Just pointing out other things to help you out. Here is code for how we set up education, code for how we do sex at birth and current gender. It says gender at birth. That probably should have said sex at birth, but the person who created this do file for me used gender. In reality, that should be sex at birth, and this should be current gender. That's the terminology we use when we report these things. If someone had a conflict with current birth and current gender, that was our term for identifying trans folks. We were using these codes to pull those people out. This gets into sexual identity. I'm not going to get into that today, but there is code for sexual identity if you're interested in it and how we do that. And further down, there's code on outness. So I wanted to share those codes and just show you where to find codes that we typically use when we're creating our files. The next thing I want to do is pull in this one. This is an example from the manuscript, and really what I'm honing in here is to show you how we create a scale. So you can see most of the time we use sum scores to create a scale. So you can see here we were using theegen command again. So we generated a variable called syndemic. We were creating a syndemic score, and we used the row total command to create this score. Sometimes the score is just a true sum score and it's additive. Other times that sum score is we want to do the average and keep it between the Likert variables. So for example, if you don't have published cut points and you're wanting to create something, then you're going to want to generate in a way where it stays between the 1 and the 5 and you have decimal places in between to create your score. It helps with interpretability. If you have questions about that, let me know. All right, I hope this video was helpful. You guys have a great day and happy coding.